So everybody, I believe the workshop that I'm introducing here is 0-day support for Hugging Face models on ROCm. Is that correct? Description. Yeah. So and Chang has very kindly agreed to give this presentation. So I'll hand over to her.
Okay, thank you, Paul. Thank you for the introduction. Hello, everyone. So it's the interaction workshop of KXSB, Vultr, and AMD today. So we have to, before everything, I have to appreciate KXSB for hosting the workshop for us. And thank you, my co-worker, Manyak from Vultr, to support us for providing the instances that we need to use today. And let's get started. So here is a brief agenda of today's workshop. First, I will give a brief introduction, and there is a warm-up session in our workshop, because I think there are only few participants online for now. So for the warm-up, we encourage we encourage every participant to make a brief introduction of yourself with 1 to 2 sentences, and then we can know each other better. But you also can skip that part if you don't want to. And after the introduction, we would give a walkthrough of the platform we will be using for today's workshop. It's provided by Vultr and AMD. After that, we can start our demo journey. So the first demo is about a text-to-image generation service launched by XDIT. And after that, there will be a chatbot service launched by VLLM. And the last one is an optional demo. We would use OpenWebUI to provide a visual user interface for our chatbot. So the goal of this workshop is to let you know how to build your own generative AI applications on AMD GPUs. So we hope after this workshop, when someone else asks you whether AMD GPUs can run AI applications or generative AI applications, and you would know the answer, right? Okay, so here comes to the warm-up session. Paul, do you think it's okay to have everybody in the channel for now to give a self-introduction of their own?
Yes, I think that's good. I think they have to probably unmute themselves. I'm not sure. At least I can't figure out how to do it. Does somebody? I think you. Should we try and start with Peter? Maybe. Peter, are you happy to say 2 minutes about yourself? If so, could you mute yourself?
Oh, sorry, I'm still coming out of the tube. Can I pass it over to Dimitri?
Yeah, sure. Are you working together as a team? Dimitri, are you there?
Yeah, I'm here.
Great.
Oh.
Would you like to say just 2 minutes about yourself, really?
Yeah, about myself and maybe about projects.
Yep.
So I'm more from engineering background, I should say. I have maybe like 20 years expertise in industry, mostly in like Java based like technology stack. Had some experience of like building AI like and machine learning like software and functionality. And now we with the team working on our idea of screenwriter tool, screenwriters tool, essentially an AI assistant tool to build and collaborate around like movie scripts. It is like not intended like to generate movie scripts content, but rather to assist the content creation and the collaboration process by analyzing a script and providing like some guidance if some aspects is not like properly fitting to like script standards, or maybe like things are not connected together, and also to streamline all the related works, because like in film industry, that's a lot of work starts from the script. Yeah. Sorry, I'm without camera at the moment.
Dimitri, that was a very good presentation. I think that's about the right length for everybody. Would anybody else like to do the same as Dimitri's just done? What about Ibra? You'll have to unmute yourself, though.
Yeah. Good morning, everyone. I'm Ibrahim. Just don't know why you live, bro. Pseudo names. I am a sort of a DevOps engineer by background, and I got into AI ML ops through digital innovations through government digital services. So I started investing into AI applications. So one of them was an image scanning tool where you could pick up objects or litter or whatever rubbish you find, and you can identify it and it can be triaged accordingly. So that got me interested in developing my own apps as well. And currently I'm using this hackathon to develop a fashion refit app where I'm using, you're getting it wrong, but I'm using plug-in face models, which I'm kind of working off collab workbooks at the moment. So I'm able to put like a control image and then blur like images that I've taken from the dump, and then can they be refactored and repurposed. So yeah, I'm learning a lot, and yeah, the part I'm interested is the text image, because that's exactly what I'm doing, and accessing GPUs, because I've found very hard sometimes to just work on Google Colab notebooks because it's quite prescribed, and then you have to use a UI, which is trickier. So I'm looking for out-the-box solutions, or some services where you have to be less, I guess, in the know of the actual tool. Yeah, that's me. And anyone else, or should I just pick someone?
Oh, thanks, Ibrahim. That's really good. Shall we ask Michael if he's there? Michael, you just muted yourself again. I think you need to unmute.
It's quite sensitive, isn't it? You do things when you haven't realised you've done them. Yes, I was there on Saturday. I proposed a project around an intelligent assistant teaching creative professionals how to use Gen AI. I've had a background in computational linguistics for a long time, following in the LLM history and development, and I'm just interested in what's going on and what comes next, and trying to keep up, which is really hard. That's me.
Oops, sorry, I was muted. Thanks very much, Michael. That was great. And Namrata, can you say anything? Again, you'll have to unmute. Yeah.
Yes. Can you hear me?
Sorry, loud and clear.
So I was there on Saturday. I have proposed the project. My name is Namrata Kokreja, and I have proposed the project of AI-powered job application assistant. I am very happy with the kind of interest with people who are interested, and we have a very interesting group, and we've started our work on this project. So yeah, my background is non-technical. My objective to attend this is to gain some technical knowledge today. So yeah, that's about it.
Thank you very much. That's great. And I think probably finally at the moment, it's probably Ataraxi.
Oh, hi, good morning. My name is Anna, and my background actually is in aviation. I am just a curious human being. But together with the team, we in 2022 we created a virtual gallery on Minecraft, which is called Square Eyes Gallery. And I am just curious to know how we can use the AI in the future and now to create a new projects and things. So thank you so much for this opportunity and nice to be on this community.
Yes, and thank you very much as well. And yeah, curiosity is a great thing. Just one final. Peter, did you want a final word, or are you okay? Are you still on the tube?
No, I came out. Thank you. So I'm Peter. I'm an AI engineer. I design, develop, deploy, and monitor AI solutions and ML solutions. I have used OLAMA, VLLM, and SGLang to deploy models on cloud and on-prem. And I would like to use Vultr and AMD for parameter efficient fine-tuning, taking basically a recipe book in the public domain and create a model that has natively an inclination to use the style of that particular recipe book. So that's from my side. Thanks. And looking forward to the collaboration.
Thanks very much, Peter. Okay, so I think that's everybody. It's some great capability in the room here. So I think I'm going to hand it back over to Chang now. Thank you very much, everybody.
Thank you, Paul. Thank you, everybody. It's really my pleasure to meet you all here. And as we have mentioned before, it's an interaction workshop. So I think each of you would receive a doc from Manyak soon, and the doc would contain,
Can we identify the individuals who require the environment for following the demo?
Okay, following what?
Following the demo as you go, as you present them, do we want to identify the individuals for distributing the access to environments?
Okay, I see. Okay, it's your call. So before that, I can make a brief introduction of the environment first. So the environment is provided by Vultr and AMD. Vultr provides the infrastructure, the cloud compute instances for this workshop. And thank you for your support, Manyak. And as we can see, each instance is equipped with an AMD MI325 GPU, which is a very advanced GPU. Each of them has a 256 gigabytes memory, which can support large language models or image generation models to run on a single one. And the virtual environment has already installed the public frameworks like PyTorch, VLLM, and XDIT. So PyTorch is suitable for building up your own AI models. You can design your models and edit your models there. And VLLM is designed for providing the serving of large language model. As far as I remember, Peter has already used that, and I think this is one of the most common used open source frameworks of LLM serving for now. And XDIT is designed for serving the text-to-image generation tasks, which can well support all kinds of diffusion models. Okay, so this is the basic introduction of the instances that we are going to use in this workshop. And also, you can apply for further access to these resources if you want to build up your applications on AMD GPUs. Okay, so as we have discussed with Mayak, we will deliver you a doc containing the access information of our instances later. So the doc would include the information listed on this slide. There will be the IP address to the instance, and there will be a password. So keep the password confidential, because each of you would have a different one. I just like hide mine, just in case anybody will steal my resource. Okay. Anyways, so talking back to the dock, there will be 4 ports listed in the dock, and you can see each port would correspond to a different application. They are SSH, JupyterLab, VLLM, and XDIT. So for JupyterLab and SSH, we would use the password to access it. For VLLM and XDIT, we don't have to use the password because they are the services we pre-launched for everybody's access. So you just can get the service by the address listed in the doc. Okay, so now I can take a brief walkthrough of how to log into our Jupyter Lab and to access some access the GPU resource on it, and how to use the pre-installed frameworks upon it. So let's get started. So first I will copy the IP address here directly to my browser. Okay, because I have already logged in before, so I don't have to input my password again. But if you first visit this link, you would be required to input your password. So please remember to copy your password according to the doc. Then you can be the page where I am now. Okay, so on this page, you can see there are a few buttons corresponding to different applications. So the first button is Jupyter Notebook, which is quite convenient for you to add it to build your own AI models. And the second one is the console for Python 3. And you can also use terminal here or markdown file. So with terminal, you can use it as your local device to input any commands under the Ubuntu system. And for markdown file, you can edit your README or the documentation of your projects. So I would take the Jupyter Notebook as the first example here. So you just click on the button, you'll create a brand new Jupyter Notebook. And just to show that we have already installed our PyTorch, I would import Torch here. So it's just very simple line. And we can click on run this cell and it's done. But we don't know whether it's installed correctly. Cannot see the demo. Okay. Can anybody else see the demo now?
Yes, it is fine.
Okay, maybe there's some networking issue with you. I don't know who prompted this question in the chat box. I forgot about your name. I didn't see your name actually. So maybe
It's
you can try to reconnect. Yeah.
Chang, it took me a little bit of time to realize that the demo was in the corner of the windows. So I just wonder whether whoever it is didn't see it in the corner. In other words, Chang Lee's got two open windows, and this is one of them. Does that make sense?
Ooh, let me have a check.
I was seeing it okay, by the way, the demo.
Okay, it's a very small window, right?
Yeah, that's right. So I didn't notice the window at first, and I was just about to ask you whether you were going to do a presentation, but then I discovered it. So who was having trouble?
No, it was like clear. I just double click it on it and that's it.
Oh,
That was
okay.
me, Michael. Which screen is it? I can see something in.
Top left-hand corner.
Yeah, but when I click on that, okay. I just get it's just not working for me, I'm afraid.
Okay, that's really strange, though, because you can presumably see all the rest of us.
Yes, indeed, but not that. Well, I can see it, but in miniature.
You can't get it to click out.
No. Options. No, it's not
You just try
giving
pressing
me
F12 or something. There might
a
be a
click
glitch.
out option either. No.
Sometimes you can full screen the chat, and then you might have it.
Yeah, I have done full screen. Actually, I'm in full screen. But,
Oh.
oh,
Well, Michael, we'll have to let
okay.
you fiddle with it.
Okay, I'll do that.
How about double
Back
click on
I'll
the
do that.
window?
Yeah, I'll figure it out.
Okay.
All
I'm sorry about
right.
that.
Okay.
back over to you, Changli.
Okay, I'll continue to the demo then. So now we want to make sure whether our GPU is correctly equipped in the instance, so we can input the function like this. Torch.cuda is available. It is a common use function to check whether your GPU has been installed correctly. So we can run this line as well. And you can see there's a true return value, which means we have the GPU installed successfully. And then there would be another one. We want to know which kind of GPU we're using now, because as you can see from the function, we're still using CUDA, but actually we're on the AMD GPU. There's ROCm supported rather than CUDA. So that would be another function. Okay, I'm not sure whether I can remember the function correctly. Just have a try. Okay, yes. So by inputting torch.cuda.getDeviceName, and you can see the exact name of the GPU equipped in the instance, and its return value is AMD Instant MI325X. So from the user experience, you will not notice any difference of using other GPUs and AMD GPU. But if you want to see what exactly the GPU installed in the equipment or in the device, and you can just use this function to check. I think this design is based on the consideration of not letting users to learn extra operations of different GPUs. So you will notice any difference of other GPUs and AMD GPUs. Okay, so if you want to have a try in the further session of this workshop, you can just open a Jupyter notebook as what I did and try to verify the GPU installation. Okay, so this is the basic walkthrough of the Jupyter Lab environment. Manyak, do you have anything to mention about of this session?
I just sent a few direct messages to Dimitri, Michael, Ibrahim, Peter. So I sent all of you a message asking if you would like to join in Chang for the demo. And if you are interested, just let me know so that I can share with you the credentials that Chang presented on her slide deck, so that each of you can have access to a MI325X instance, and you would be able to follow one with each step that Chang does on her screen. You will also be able to replicate it on your screen, so that you also learn alongside how to spin up XDIT for spinning up a inference endpoint for image generation model, or how to spin up a VLLM inference endpoint for a large language model. So I have got a few replies, so I will be on
Yeah.
the lookout. Yeah. All right. I am sharing with everybody the credentials and let me know if you have any issues.
Can I have a question in the meanwhile?
Okay.
So CUDA is this, maybe I'm saying it wrong, but so this is an SDK software platform, right? And it has versions. Do you know which version is supported in this case?
Okay. Actually, in our environment, it's not CUDA actually, but we use the same functions defined in PyTorch or any other higher level applications, just in case to ensure that the users would not notice any difference of using AMD GPUs or NVIDIA GPUs. So here, below the CUDA, actually we installed ROCm. So Manyak, what's the version of the ROCm we're using here? I guess it's 630. 6
Yes,
point.
it should be 6.3. You can use ROCm SMI on a terminal.
So the CUDA version is around 6.3 or something, or it's the underlying infrastructure. I'm just asking it
So
because
yeah, just
yeah, go ahead.
reframe. PyTorch, it has a function CUDA, which is linked to the ROCm environment when it's a AMD GPU. Even though we don't have CUDA in AMD,
Yeah.
but PyTorch, for the sake of maintenance and not having everybody go and change their code bases, they just defaulted to using CUDA even for AMD. But when you are using AMD, it's a ROCm, which is the alternative to the software stack from NVIDIA, which is called CUDA. In AMD's side, the same software stack is called ROCm. And just like NVIDIA SMI on AMD CPU, AMD GPUs, you can run a similar command which is called ROCm SMI to fetch the details of your GPU. And I think uh, it does not show the version with the default flag, but
Yes.
we would have to use ROCm info,
Yeah.
just like
ROCm. So this is ROCm info's output.
I can confirm for you that it's 6.3. I just checked on my side.
Yeah, there should be some information here.
Right, because it's a big verbose
Yeah.
output. You would not be able to find it here. I'll paste the command for everyone else to try on their chats.
Mm-hmm.
I think we can continue.
So it's a neat question, but so CUDA and ROCm are the same capabilities with a different compute.
Yes,
Like,
one of the main queries that I'm glad that you all have these questions, right? Because one of the main purpose of this workshop is demystifying some of the misconceptions while using AMD GPUs for machine learning workloads. Most people assume that since AMD lacks CUDA, they would not be able to run machine learning workloads similar to NVIDIA GPUs. But as you can see, even in PyTorch, which is a most commonly used abstraction language for writing your machine learning workloads, it treats ROCm environments the same as CUDA environment, right? So that would mean that you would have same capabilities, if not better, on AMD GPUs. More specifically, the AI GPUs that AMD has released under the AMD Instinct brand.
oh, thank you. That makes sense. So it seems like whoever like PyTorch, is it on them to make sure it's compatible and Hugging Face to make it compatible?
Yes.
So,
So
okay.
since PyTorch supports it entirely and is able to run just as as it would run on an H100, uh, that would mean that we would have 0-day support for anything which is built on top of PyTorch, and it is um, I do not want to quote big numbers, but i- if you see a new model, there would be PyTorch used in some capacity, uh, and you should be able to run it on a AMD GPU just as you would run it on a NVIDIA GPU, ideally. And that is what we are going to demonstrate today.
Yeah. Okay. So, um, if everyone has already obtained your confidential information from Mayank, maybe we can proceed to the interaction demo session.
I'm ready.
Okay. So in our demo session, we have 3 demos. The first 2 are the basic ones, and the third one would be an optional one. So the first demo would show how to launch a text-to-image service via XDIT on AMD GPUs. We will use a small diffusion model named as Flux. And here comes to demo 2. In demo 2, we're gonna use VLLM to serve a DeepSeek model to behave like a chatbot on AMD GPUs. And the third demo is for visualizing the chatbot using OpenWeb UI. So let's get started. I just want to make sure everybody is able to access to our instance now. Mayank, shall we wait for a few minutes to have everybody's on board? Or shall I get started directly?
I shared with everyone who texted me on the direct message
Okay.
with credentials, so I think you can proceed.
Okay, nice. Okay, so there is a tutorial provided by Vultr indicating each step of launching the text-to-image generation demo. So I will send you the link in the chat box. I'm really new to Discord. I don't know how to send a message to y'all. Let me have a check.
Yeah, I can't see the message. There must be somebody with all these technical people here. There must be somebody who knows the message where the message is. Dimitri.
On the top right.
Top right. Oh, yeah. Thank you so much. Yeah. Okay, so this is the tutorial for the first demo. Okay, please open the page or just view it through my shared screen. We just scroll down to example, run inference endpoint for Flux point 1 Chanel. Okay, nice. Peter has already logged in. Okay, so yeah, make sure you have already logged in onto Jupyter Lab, and I will get started now. So I will open a terminal first, and let's check the directory we are in now. So we're on the root, and let's list the folders in current path. There are 2 folders, Jupyter Notebooks and XDIT entry points. So XDIT entry points are the default directories for XDIT to read all the model weights in local. Okay, so before that, we can download our models from Hugging Face first. So Flux point 1 Chanel is a non-gated image generation model So we don't have to input any Hugging Face token into it. Okay, after inputting our increase font size. Okay. Let me check. Okay, how about now? Is that large enough?
Yeah, thank you.
Okay, it's okay. Okay, so after inputting this command, we would have our model downloaded in local. And then, as I've mentioned, we hope to navigate XDIT to its default directory to load all the model weights. So we have to link the downloaded model weights to our preset default directory. So after inputting Hugging Face -CLI scan -cache -v, we can see all the downloaded model weights under some cache directories. And all we need to do is to link the downloaded model weights to the default directory. Okay, actually I have done this before. So if you input this in your terminal, there will be no return value. Okay, just to check, we have
Did
already.
you paste the command in the
Yeah.
actual? That doesn't
Oh,
give
yeah. Yeah, about
That
pasting the
doesn't give
command,
it
you
that.
have to use keyboard. You have to use keyboard. You cannot use mouse operation. Yeah, so by using Control and C, you can copy the command, and then switch to the terminal view. You can press Control and V, then you can copy the command. Okay, so let's have a check of our linked model directory. So there will be a flux.1 -Chanel folder under the directory xdit entry points /models.
Yep, mine's the same.
Yeah, okay. Everybody's all set? Okay, so let's move to the next step. So this step would help us launch our text to image generation service. It might take a while. You can see from the output, the engine is loading the model weights. Okay, when you see info model initialization completed, the service is up. So, okay.
Mostly there.
My service came up in errors. Right?
Sorry?
My service started on Ray instance, and then it says I get a value error.
Ray instance.
Uh,
Oh yeah, and then you should wait for more time. And when
okay,
it
yeah, sorry,
says
one in
main,
PIT, yeah. It's just
yeah.
running is taking up the shell account.
Okay.
Yeah, and mine's ready as well.
Okay, nice. Okay, so now you can open another terminal, and then input ROCm SMI in the terminal, and then you can see there is a 14% of VRAM has been taken. So it's actually taken by the flux model. Okay, so for now, we can further check or further verify we have already launched the image generation service by the fifth command, the fifth step. So this command actually send a request to the service to generate an image based on a prompt, including acute rapid. So, okay, we got a return message from the service then, and you can see there would be a generated image under your folder, and there's a cute rabbit. And you
It
can
is.
sense from the speed. Yeah, it is. Okay, nice. You can sense from the speed the compute capability of MI325 is super fast.
Yeah, the image is loading way longer
Oh, okay.
than it was generating.
Can you tell me again the command for monitoring?
Monitoring? Which monitoring?
Yeah, the SMI, ROC.
Oh, ROCm SMI. Okay, I can show you again. Oh, sorry, there's no backtrack. ROCm-SMI. Yeah, it's quite similar to NVIDIA SMI actually. And it
I
will
have
show.
technical question.
Yeah, okay.
This monitoring command shows GPU load percentage, and like I have heard that for, I believe, NVIDIA hardware, it is either 0% or 100, and there is like nothing in between. At least like some people like tell this on Rust Meetup. I don't know, like, is it true? And if like your hardware provides a more granular perspective to GPU load at the moment, like
Oh,
to monitoring.
you mean the GPU utilization for now is
Yeah.
0%?
Yeah. So like,
Okay.
can it be like 25%, or it is like being reloaded or not loaded at all, and no more detailed information?
Oh, you want to see more information or?
I'm just like curious if it is like real percent or it is like just 0 or 100.
Oh, okay, it's a good question. I haven't never noticed about that.
You mean on NVIDIA SMI, you usually see either 0% or just 100 and nothing in between?
Okay, yeah, that's what I'm like asking.
So,
Uh,
um, for me, I have actually used NVIDIA extensively, as we at Vultr also offer NVIDIA GPUs. And I was able to see the percentages in between just fine. So I think it depends on how much VRAM and how much tensor core processing that the model is taking up initially. I would imagine one workload where it would mimic the behavior that you just described. It might be a large model which consumes the entire GPU all at once, and I think that's why it would just go from 0 to 100. But now that both NVIDIA and AMD are
thank you.
coming up with bigger chips, so MI325X has like 256 GB of VRAM, which is hard to use with just one image generation model.
Yeah, thank you very much.
Okay. And also you can monitor the utilization of the GPU in real time by typing this command. And then when you send up a new request to the service behind, there will be different utilization of the GPU shown on the screen. So this is our first demo. And if everybody's done, we can proceed to the second one.
Just a quick question. Do you know if you are supporting also whether we can monitor with NVTop, which is just another tool for monitoring GPUs?
What's the name of the tool again?
It's written as NVTop, so November, Victor, Tango, Oscar, Papa, NVTop.
NV. For now, maybe it's an NVIDIA product, right? It's an NVIDIA tool. If it starts with V something, then there'll be.
I'm checking if it's.
Okay. Okay.
Right, hold on.
Oh, AMD GPU top. Yeah. Some of my colleagues are using this tool as
Oh,
well.
nice.
Mayank has already sent this to the chat box, right? Okay. Okay, so let's proceed to the next demo then, considering of our time limit. So in order to leverage the whole capacity of the GPU down there, I suggest you guys to kill the image generation task for now. Just by pressing Control and C, then you'll kill the service. Okay, so let's proceed to the second demo. So the second demo is to build up your own chatbot using VLLM on AMD GPU. And similar to the first demo, we have to download the checkpoints of the model first. So we copy paste the first command of downloading DeepSeek model weights in local. I have downloaded it already, so it just takes only 1 second. But from your side, it might take around 1 minute to download the whole package of the model weights. So DeepSeek R1 Distill Q132B, the model we're using now, is non-gated on Hugging Face. So you don't have to input your Hugging Face token as well. It is a smaller version of DeepSeek R1, which can be run on a single MI325 GPU. Yeah, Mayank just sent the tutorial of this demo in our chat box. I'm sorry, I didn't remember to do that. Thank you, Mayank. Okay, so after downloading the model weights, we just input another command to start the large language model service. It's quite simple by using VLLM serve and our model name, DeepSeek AI, DeepSeek R1 Distill Q132 billion. And then you'll have the LLM service launched. But we need to wait for some time. Okay, meanwhile, we can monitor the usage of the utilization of our GPU for now. So you can see the GPU utilization increases from 0 to some other numbers and to 100% for now. And after loading, I guess after loading the whole model on VRAM, the GPU utilization decreases a bit. I mean, a lot. It's not only decreases a bit. when you see application startup complete on your screen, the service is launched successfully. So everybody's with me now, right?
Yep.
Okay, nice.
I'm having trouble even just accessing the link that was shared. But
Oh.
that's probably what it means, so go ahead.
Oh, which link? You mean the
The
virtual
one
log?
that ends with revision 4575. Somehow, but it's probably only me.
Mayak, do you know how to?
The link works fine. Yeah.
Okay, then it's on my side. Sorry.
Maybe should try to refresh or something.
The link works fine on my side as well. So I can, Peter, I can assist you after the workshop if you're still facing issues. We can always reach out.
Yeah. It's on my side because I'm watching the video on the phone and I'm using the computer. And when I'm copying the link, I'm making mistakes. So it's on my side.
Dimitri also just
I mean,
pasted the command which is required for you to run.
yeah, if that's okay, like I will stop like making a noise. Sorry. A, a tricky question, like as a follow-up to this, like GPU load question. So probably GPU temperature might be like a good approximation for the GPU load.
If you see there, the output is currently little mangled due to the zoom of the screen. Uh, but the numbers they are overlapped with each other. The 81% which is shown on the second last column, that is the percentage of VRAM which is getting used. And the last number which is on 0% right now, that is the stream process usage, which is currently at 0. So that you mean you already know that GPU is not under stress. But as soon as we will send some inference requests using curl, you will see this usage going up, and you don't really have to see the temperature to know. Uh, Although it is a good indicator, but since data center tech is also getting very, very advanced with liquid cooling and other advanced cooling techniques, temperature may or may not be able to resonate with the full granular usage that you may need to monitor. So that is something. Maybe Chang, can you zoom out and people can see it in a better manner?
Okay, let me kill this first. Okay. Oh. Oh, it's still folded. I don't know why.
Yeah, it's no worries, but in the credentials, you guys will also have access to SSH using the port defined in your credential file that I've shared over with everyone. And on over SSH, the output may be better. So yeah, I hope that answers your question, Dimitri.
Yeah. Okay. Thank you.
Okay.
Just a quick question. On my one, I get, and maybe it's just a DeepSeek model, but max tokens, is that 5112? Is that the maximum I can take from on actually, that's from the call request. So generally, this can take more tokens than this DeepSeek model on AMD
Oh,
GPUs.
you mean send the? You mean there's a limitation of the tokens
Yeah.
we send to the service? So if we
Yeah.
launch the service in local, there should not be token requirement. By
Oh no, because
token,
in
you
your
mean
call
input
request, it
sequence
says
length.
max
Or,
tokens 5112. Is that just from the response you mean? The actual, I mean, in the Vultr docs, the
So when
actual command.
to the last command in the doc,
This one,
uh,
right? Oh,
yeah, this is a request that you're sending to the service, and
Yeah.
this
So you've asked
yeah,
for
this just
512.
means
Yeah.
that you would want 512 tokens as a maximum limit set, but you can change that dynamically depending on your requirement.
Yeah, I thought it was something related to the fact we're using DeepSeek on your on this for this movie. But generally, how
I,
much tokens can
I
you
I
really
think you
command?
can go all the way up to 128,000 tokens for DeepSeek.
Okay.
yeah. So after sending the request to our launched chatbot, we shall have a response from the service soon. And in the demo command, we ask the chatbot to answer us, tell me about AMD Instinct GPUs. So it has generated some output for us, and we can see you need to tell someone about AMD Instincts, blah blah. Yeah. Then
So it concluded well because it's a reasoning model. So in the reasoning tokens, it started off by not being very familiar with AMD Instinct, but then
yeah.
it figured it out, and it outputs that it's suited for high performance computing, AI, and machine learning. So that is good.
Yes. So I guess that's all for the previous two demos. Everybody has got your response now.
Yeah. No response.
Okay, nice.
So, another question. If you're on the
Mhm.
CLI, I just want to view the image. Is there a way to view images when you've SSH onto your machines? So, like, I have that image, the first thing, generated image. But if you're on, because the web link didn't work for some reason, I think I have some settings. But if I just have a command line session with your instance and I want to open the image, do you have, is that a command I just don't know?
So there is over SSH, you cannot open an image conveniently, but you can use the same credentials to connect over SFTP if you are familiar with that, because it utilizes the SSH.
Oh
Uh,
yeah, that's the same as the
yes.
okay. And if I need help accessing HTTP, can I just come back to this chat later? So it doesn't seem to be. It just gives me no login like page.
Yeah. If you
I'll message
mean,
you directly, maybe.
okay, yeah, I can assist you there.
And also, as far as I know, we have set up a listening service of XDIT, right? And maybe you can send requests to the service and get the response to local applications directly.
Okay.
That is also true because there is a listening service. Chang just mentioned that there should be a mention of the last line there. XDIT service listening on default port 6000. And depending on what environment you have, Ibrahim, you should be able to get the URL from there and make the same request using your local system instead of SSH. So it will come over internet.
Okay. Thank you.
Okay, so I guess we have time for the optional demo. Are you interested to try more about the Open Web UI, guys? Okay,
Mm.
so let's do
I know.
that. Okay, so the last demo involves involves to use your local device. So you have to install OpenWebUI in your own environment. Okay, I will show how to do that from my side. So I'm using WSL, this terminal, on my laptop. And you can also use PowerShell or some other Ubuntu or Mac OS terminals. Okay.
Can I ask to share the link to that
Oh,
tutorial?
yeah, of course. I'm sorry. Let me copy this for you. Okay, so first, when you turn on your local terminal, you can navigate yourself into a workspace directory. So mine is, okay, mine is under here. And for now, you have to make sure that your Python installed in your local environment is higher than 3.11 or 3.12. I think 3.12 will be better, but yeah, the minimum should be 3.11. So you can check your Python version by the command Python 3-v. Oh, mine is 3.10. How come? As far as I remember, it should be larger. Okay,
I
anyways.
think I think your virtual environment might have a
Yeah,
more
my virtual environment.
more recent version of
Yeah,
Python.
nice. It's really fun. I'm sorry for that. I didn't expect. Yeah, it's a 3.12 in my virtual environment. Okay, so you can also build up create a virtual environment using the command shown in the tutorial, Python 3-m virtual environment, OpenWebUI. And then you can activate the virtual environment by source, OpenWebUI, blah, blah, blah. Okay, so within this virtual environment, we have to install OpenWebUI by pip install OpenWebUI. It might take a while because from my side, it took over 10 minutes the last time I installed this package. Okay, nice. I have already installed OpenWebUI from my side before, so that's why it's quite efficient from my side this time. Okay, nice.
Oh yeah, UV is a alternative to pip. It's written in Rust, so it is a bit faster than pip. In my experience, there is a drastic difference when you are installing these packages using UV. So that is a great advice from Peter as well.
Okay. So everybody has already installed OpenWebUI already, or it is being processed?
No, mine is in progress.
Okay. So I can proceed for the next steps first, and then maybe you can.
Yeah, we can move on. I will catch up. No worries.
Okay, thank you. Okay, so after that, we can start our OpenWebUI by input the command OpenWebUI. And you can also indicate specific port if you want. But for my side, I would just use the default one. It would also take a while. Yeah, it's not up yet.
Now it is. It's a bit tricky because they show the graphic and it doesn't really work right away.
Okay. The tutorial is also available for Windows because on my laptop the system is Windows. So
But I think
Then
you may not be facing issues because you're using WSL. So I'll accommodate to that suggestion. Thank you, Peter, for making that.
okay. So I have already logged in to Open Web UI before, so I already got the DeepSeek AI, DeepSeek R1 Distill Q1 32 billion model loaded. But for you guys who first use Open Web UI, there should be no models here. So you can follow our tutorial to set up the connection to our launched model using the URL here. And make sure to also copy your model ID to the description of the connection.
Sorry. So what we are doing is that we just create a client locally so that we can connect to it. Is that what we are doing? Like a UI for a client locally, and we connect to the server? That's kind of the goal at this moment.
Okay. So your question is what are we doing now, right? So we started our large language model serving on AMD GPU on virtual cloud instance. So we hope to access to the service using our own devices, like our own laptop or desktop, or even mobile phone maybe. And so locally, we first install the Open Web UI in our environment, and then we build up a connection to the service that we have launched on virtual.
I think you said close that service.
Pardon?
Because I thought we said close your DeepSeek LLM. I thought you said close it for the next moment. But you're supposed to look to open one.
Oh, sorry, I didn't quite get it.
Yeah,
In my
the DeepSeek that we started in the last session, in the last
Mhm.
tutorial, were we supposed to have closed that or leave it running?
Oh,
You
you can.
you leave it running. And yes, this is
All right.
essentially just
Yeah,
creating a
you did say
client.
close.
Yeah.
Okay.
Yeah, the DeepSeek we're indicating now is actually the one we launched in the second demo.
So, yeah, 'cause, I've closed it, so I think I thought you said close it.
The second, I mean the demo in the second, I mean the second demo, we should keep it. We don't need to kill the service when we use the Open UI to Open Web UI to connect to the service. Am I making this clear?
Yes, I just have to serve it again.
Mhm.
Run the same appearance.
Okay. So if you can connect, you can create a connection as we can see on this page, and then you can type into any question to your chatbot. Like, yeah, as far as I know, there's a good question from my colleague to ask it. Okay, let me think of it. Let me think of some question, or maybe I can search for the history. Or do you guys have any questions to ask to this chatbot?
Are you sentient?
Oh, you can see there are some like suggested prompts generated by Web Open UI directly.
Why Open Web UI takes so long to start?
Yeah, I was thinking of that too. It's not started yet, right? From your side. Oh yeah, Mayank got it. Nice. This is our pre-test prompts. So our question is, imagine facing east, turn 90-degree left, then 270-degree right, then 180-degree left. Which direction are you facing? Actually, you're like in the original place again. So there are a lot of reasoning processes generated by DeepSeek and we can see the answer is. We can also request it to generate some Python code for us.
In the meanwhile, I'm trying also another connection, which is an extension on Chrome. It's called Page Assist, but I don't. It doesn't pick up by default the model type. Um, do you happen to know what I should put there? It recognized that an OLAMA compatible service is running on the host, but it cannot identify the model. Probably that's because we are using a model that is already like 2 months old.
Oh,
Yes, I think. Uh, can you let me know what the API URL base did you enter?
Um, yes, I entered the wrong one. I think I entered. Yeah, that's my mistake. I entered the Jupyter Notebook URL. I have to enter something else.
Yeah, and it should be the second last line in your credential file that has. It would be the same URL that you use on OpenWebUI.
okay. I think if you have got the OpenWeb UI all set, then that's the end of our demos today.
Mine is not, but the steps are clear, so I will complete them later.
Yeah, it might take a while to install Web
Yeah,
UI,
it's
Open
not
Web
enough
UI.
on my side.
Yeah, and to start it also takes a while.
Thanks, Chang.
Okay.
Mayank, do you have anything to add to the session, or is that about it?
Yeah, no, I mean, this was a workshop presented by Chang, and I'm just here to answer some questions. So that was me.
Can can I have one
Chang,
question instead?
yeah, sorry, that's what I was going to say. Do we have any last questions?
From my side, I don't have any questions, but I'm curious about whether.
Do we get to keep these environments for how long?
Oh yeah,
You
Or
can
just
you can keep these
the
environments with you for the entire duration of the hackathon. And I will be sharing shortly after on the channel for the people who are watching this video on YouTube. We'll share a link to request for an access to one of these environments so that they can also go through the same demos, but not only limited to demos. They are able to use these instances and adapt to their own machine learning workloads. Peter mentioned, and some other people mentioned that they would want to use a GPU for parameter efficient fine tuning. That is certainly something that they can do on this environment, because it allows you to connect via Jupyter Lab or SSH, depending on what you need. And it comes with pre-installed PyTorch, which can be utilized for the same, and VLLM uh, along with XDIT, which may be instrumental if you just want a inference endpoint to connect to your Next.js application, React.js application, or any other no-code, low-code websites that you're creating for the hackathon, right? So each instance that people have got, they can keep to themselves, and we also have like at least 24 environments which are left with me that are free to claim right now, and I would be distributing one per team who are interested in procuring the access to this.
Thanks, Mayank. And Phil, I think we've recorded everything, so it'll be available on the YouTube channel. Sorry, on the YouTube channel. Do you want to say anything about that? Fantastic. Great. So I think if there's no more questions, just left to say thank you to Chang for the presentation and everything.
Can I have a quick question? Is that on? Is it possible to monitor this resource on Vultr?
So since this is a GPU instance that is linked to another account on Vultr, not a customer account. This is the POC account that we have. It wouldn't be possible for you to as monitor the resource on Vultr uh, in this state. But
Got
you
it.
can
Okay.
always use the serverless inference product. Vultr.
Okay. Do you have any, just last one, in case we run into out of memory messages, do you have any recommendation to see what we should do? Is it monitoring the memory or anything else?
So the first one, in the both the docs for XDIT and VLLM, they have a snippet of text which lets you gives you awareness about the running terminals and the running processes. The first advice from me would be to keep in check the running processes which are consuming your GPU. And if you have taken care of that, yeah, and your model is just large, which is not able to fit into 256 GB of VRAM, then I would suggest that you try to use custom flags by VLLM to run a quantized version, or run a lower uh, um, FP FP16 version or FP8 version on the GPU, so that you are able to utilize less VRAM and get more out of it. So that would be my advice. And I am always available either on the Vultr thread under LPB25, and for some of you, I have also sent them a direct message. So I'm always reachable. I try to be online as much as possible. So I would be able to answer any queries later as well. And for the people who are watching on video.
Fantastic.
Great.
Okay, so thank you very much. I think we'll call it a wrap for today. Anything else, just contact either Mayank or Chang offline or on Discord channel or wherever. But thank you very much, everybody.
Thank you. Thank you, time and attention.
Guys,
Thank you. Bye bye.
bye.
Bye.